All right, so we're on service-oriented architecture. So service-oriented architecture are stateless. It's very similar really to microservices. But the idea is we have stateless components, which means that they can be replicated and can migrate from one computer to another. In other words, there's just this thing that, I'll give you an example. My best example I can think of is like a weather server. It just tells me the weather today in Jerusalem is. You know, I can get a city and it'll tell me what the temperature is in that city at that moment. So it's stateless in the sense that it's not keeping track of, it's not like if I ask it twice, then it's going to give me a different information. It's not going to keep track of how many times I asked it. It'll always give me what temperature it is at that moment in that city. And I can migrate it from one server to another because there's no data that will be, as long as I put the service on another server, I don't need to keep track. I don't need to also send how many times this person asked this information or what state he was along the path of asking for information. Right. In other words, if you think about it, what is stateful? What's the best example of a stateful service? It would be like a login, right? First I log in, and now it has me logged in, and now I ask for the weather. So it only works if I'm logged in. So that's like a state. It has to keep track. No?
Well, no, because it can still be stateless and it's keeping track of the login for cookies, which is I think what most things can.
No, if it can't keep keeping track of the login on a cookie by me, but in other words, it has to get a token. It has to get an authentication token from me, and every time I will have to pass it. If what you're saying is true, right? But every time I'll have to pass it my authentication token plus my request, right? Then it would be stateless. If every time I sent it. Right, but if it knows that I'm logged in and therefore accepts requests from me.
But I'm saying the way it keeps you logged in, like the way when you're logged in, and let's say you press on another product, right? You're on Amazon, you're logged in, you press on another product, it reloads the page, but it doesn't necessarily mean that it's stateful, right? Because it could still
have the state on by me. Right.
Right?
Yeah, you're right. You're right. And it's going to work.
I know I'm talking confidently, it doesn't mean I'm right. No, I'm saying.
Which confidently you must be right. Maybe not.
I'm saying it doesn't mean I'm right.
Yeah. No, the way I didn't talk about security, but the way security is going to actually work is that you log in and then you get a token he sends a token. He sends some kind of data back to me, and then I send it back to him every time to show that I'm that same person. Mm-hmm. Anyway, a service-oriented architecture is usually easier to scale because I can just add more servers. I can have another weather server. If a lot of people are going to be asking for the weather, I can have lots of servers to do that. Okay, so here we have something called, here's the web server, which has like 6 different services, service 1 through 6. And that he goes to a gateway to ask for those services. Now, it could be that there'll be multiple versions of service 1. Okay.
What does that mean? Multiple versions of one server?
Yeah, no, there's this S1 is not really server 1, it's really service 1. In other words, if I want service, let's say this is the weather, this is the temperature, this is the temperature, this is the, I don't know, the certain news information, I don't know, whatever, different services. I don't know what the other services are. My favorite one is the temperature. But I could have multiple servers. I could have multiple S1s. I could have multiple servers that provide weather information.
Because like if lots of satellites.
No, because if lots of requests are coming. If I'm getting millions of requests.
The CNN has like 5 different servers because it can't take all.
Yeah, that would be, yes, exactly. So I'll have, for every service, I may have multiple servers.
Okay.
The service may be, like it may be that service 1 and 2 and 3 are all on one server, and 4, 5, and 6 are on a different server. We're abstracting away from the server. We're talking about the service. We're thinking of it in terms of service. And this service gateway is just going to, I'll talk to him and he'll be like kind of a load balancer / service finder. I'll just ask for this service from the gateway, and he'll get the actual information and send it to me. All right. Skip that. Right, we talked about should you choose a rational, these are technology choices in your architecture. You have to choose what kind of database. We talked about SQL and no SQL. What's the difference between SQL and no SQL? No SQL means that we don't do queries like joins. Basically, it means we don't do our joins. You know, in SQL, you do like a join.
Yeah.
So no SQL means it's all flat tables. All the information is in one table. So I don't do join. And we say that that's good. Why is that good? Because if I have very large tables and I need to divide them over multiple disks or over multiple servers, I can't do joins. It's hard, or it's very difficult actually. I think nowadays you can, but it's very difficult to do joins over a single table which is spread out over multiple servers. But if I don't need to do a join, I just need to find the row in the table, then it doesn't matter that it's on many servers. I'll scan one server if it's not, whatever. Let's say I know the row number, so then I just know which server to go to.
What's so hard about doing a join over servers if it's just accessing information anyway?
Well,
'Cause then we
SQL
know
is
where
not
to
built
put
for
it?
that. SQL is not built for that, put it that way.
Okay.
SQL is a server request. I log into an SQL server and I say join with these three tables. There's no mechanism in SQL to tell it, well, actually join between these tables and they're also spread out and those tables look for them on this server. There's no field to say server name : table name. You know what I
So
mean?
when we're using SQL, that means it's all one server.
Yes. I mean, you could have multiple.
Whenever in life are we specifying server? No, never. It does it on its own.
Well, normally you log into a server and then you do your SQL query.
Oh.
But if it's on multiple servers, so which server are you going to log into?
Fine.
Who are you logging into?
Yeah.
You'd have to have, if you would do it any other way, you'd have to have some kind of a remote login where I'm remotely logging into multiple servers simultaneously to do a query.
Right.
It would be, I don't know, I mean, I think it exists now, but originally it didn't exist. And so there's no SQL, which allowed you, let's say you know where the index is. I want index number 4,000. So you know that the first 2,000 are on this server and the second 2,000 are on this server. So you'll automatically go to the second server. So the same table is spread out, but you know which table to go to. So but that only works if you're not joining, because joining you can't know where it is because it's the combination of many tables. Platform that's the database question. Platform, should you deliver your product on a mobile or web platform? Nowadays we do both, right? Mobile app or a web platform. Usually you have both. What's the difference in a mobile app and a web platform?
One is on your phone and one.
Both are on your phone. You can go to the web page on your
That's
phone.
a good point.
Wow.
It's formatted differently. It looks a lot better when it's
Well,
for your
what's
phone on the phone.
Yeah, but what is the technical difference? I mean, the technical difference is obvious that with an app, you have to download special software on your program, on your computer to communicate with it's like proprietary communication. I put my bank software on my computer and then I log in and it talks to my bank over IP, over TCP IP, but it's not web. It's not over HTML. In other words, it's its own communication system between in-house software and in-house software. When I use a web, I'm using a generic software that's from somebody else, from Google.
So it's safer to download their stuff, usually.
It's probably safer to communicate with your bank through. I mean, it's not really safer because they already built all the security
Well,
for the
let's
web.
say not a bank, because obviously they know their number one priority is
What's the
safety.
real difference is not safer or not safer, although it could be. But the main difference is who's doing the computing. First of all, if it's an app on my phone, then I'm doing the computing as opposed to them, which means that it could be faster as opposed to it's less load on them. So they prefer it. And they prefer me to use my CPU to do the work. But it also could mean that there's less information having to transfer. It could be that I've got everything internally. I don't even communicate. It could be I lose communication. I can still do stuff. I'm less dependent on the communication. Server, so that's platform. Server, should you use dedicated in-house servers to, or design your system to run on a public cloud? If a public cloud, should you use Amazon? Now, should you have your own servers or should you use AWS? Open source, should you use an open source solution that already is out there? Development tools, what tools should you use? Okay. So here we're talking about databases, I already mentioned. An example of no SQL is MongoDB. I think this sentence is wrong, but maybe I'm wrong. No SQL databases allow data to be organized hierarchical rather than as flat tables. This is maybe another aspect that I didn't talk about. What was?
I was talking about that in relation.
You did? Hierarchy, I'm not sure what they mean by hierarchical. Maybe it means that there's a table to a table, and that's how you have multiple tables over multiple machines. Yeah, I think that's what he means. It's confusing the way it's written here. I think what he means hierarchical, he means that you can have a table to a table. So I can go to this small table, which tells me where all the data is. And then that data can be spread out over many servers. That's kind of like what I was saying, if I know which server to go to. But I'll have to have maybe a hierarchical, like a top level table, which tells me where all the data is, which you can't do with SQL. But he's using the word flat table in a different way than I use it. These are issues with using an app. These are mobile issues. It means app issues. If you're using an app, then you have to realize that your mobile phone doesn't have the greatest processor. You may lose connectivity. You may want to minimize how much power you use because he's on a battery. You may want to give him an on-screen keyboard so that he can do stuff. Or maybe maybe not a keyboard, maybe simplify, make the buttons bigger, you know. So that's why you have a separate browser-based and mobile version of your product, of your front end. Server.
Let's do.
All right. Open source, you know what open source is. Server, you know that it makes sense to use the cloud. Open source means free software. Development tools, like which technologies you're going to use, which frameworks. Okay, that's the end of that chapter. What chapter was that? Wait, that was chapter here. Cloud-based. Yeah, let's go. I don't know if we can do this really. Oh, it's not. Cloud, we know what the cloud is. It's scalable, it's resilient. It's startup time is cheaper. You pay per month. You have virtual cloud, which allows you to have you can have virtual machine. What is a virtual machine?
It's all compartmentalized.
It looks like this here. I don't know why this is in cloud, because you can have a virtual machine. This is just explaining how the cloud works. I think that's all why you can have a virtual machine on a server in your backyard or in your basement. So the idea is like this: you have your hardware, you have your host operating system, and then you have a hypervisor that you install on top of that. This is actually, I don't like this diagram. Yeah, I don't like this diagram. What don't I like about this diagram? Can anybody guess what I don't like about this diagram?
It's not laid out right.
Yeah, what's not laid out? What don't I like? Which box would you remove? What I would like to remove?
Hypervisor should be on top.
No, the host operating
Host should be
system
somewhere
shouldn't be
else.
there. Shouldn't be there. In my opinion, it was like this at one point. It was like this at one point. You put it in Windows, and then you put the hypervisor on Windows, and then you put Windows on top of it, on top of the hypervisor, right? The hypervisor is what allows these operating systems. I mean, this is of course an operating systems. I don't know if we go into it too much in operating systems. I don't think I do, but I did once in the past talk about it. But the idea is that the guest operating system needs to get to the hardware. But so does this guest need to get to the hardware. What if there's a conflict between, they're both working simultaneously. What if there's a conflict? We need somebody to resolve conflicts. That's the hypervisor. We can either do it in one or two ways. We can have the hypervisor work and then he himself talks to the operating system. Or we can have a hypervisor which is an operating system, which is a specially designed operating system to manage other operating systems. And then I install the hypervisor directly on the hardware. You see what I mean? This layer is kind of superfluous. This is a virtual machine.
What's the point of it?
The point of it is that I may have a single server, but I want to divide it up into many servers. Like I'm going to have, let's say like this, I'll put it like this. Let's say Amazon is selling 1 million servers to the world, but they actually only have 10,000 servers. So what do? They take each one of their servers and divide it into 100 servers. And they sell this virtual server to you, this virtual server to her, this virtual server to her. Everybody's got their own virtual server. That it also enables them to have a level of abstraction, which is that they could transfer the virtual server to another machine. Let's say that they need to update this machine. Let's say this hardware is too old. I think they have a rule, by the way, at Amazon that they change their hardware every like 2 years or something like that. They don't wait for things to break. In other words, they just swap it out immediately. They just, so if you have a server up for 4 years, I'm sure they've developed a method to move a virtual server from one server to another. We can only do that if you have virtual servers. Even if I have the whole server to myself, I should still be a virtual server on the server. Even if I've got all the computing power to myself, I should be virtual so that I can be independent of the hardware. I can swap out the hardware and swap in different hardware. That's the idea. How exactly that's done, I have absolutely no idea, because it seems very difficult to me. How would you move it in a live circuit? I guess you'd make
Meaning where it never stopped running.
Yeah, you maybe.
Is that possible?
I'm saying I don't know. Maybe you would make a copy of it. You make a copy of it, get that running, and then transfer the IP, and then all the communications would be to the other one. Something like that. You know what I mean? If you just say now just change the names. So that's why it's here, because the cloud provider is going to use the virtual server. So this is one system, and I was just explaining how I think the hypervisor, well, nowadays sits directly on the server, on the hardware. You don't have an intermediate host operating system. You put Windows there, and then Windows again. It's kind of dumb. Then we talked about container. We watched that video about containers, right?
Mm-hmm.
Why? Look at this picture. How this picture is not inaccurate, in my opinion.
Not inaccurate?
Yeah, not inaccurate. As opposed to the other one, which I thought was a little bit inaccurate. This one is correct.
Why? It's exactly the same.
No, there's
Oh,
no.
it doesn't have guests?
No, now we do need the host operating system. We do not have a hypervisor. We have a container manager. We do not have a hypervisor. What's the difference between this picture and the other picture?
There's no guests here.
Leora, you're with me? Yeah. Yeah, you're looking at this slide or some other? All right, whatever.
There are other tests of warriors.
What?
I said there's other exams of warriors.
But then now you're here.
That's true.
Class will be over, don't worry. Container, so what's the difference? What's the difference between this picture and this picture? Here we have a hypervisor, here we have a container manager. So it sounds like the same thing, but that's not the real big. What's the real big
There's no
difference?
guests here to manage it, whatever.
What? Guess what? There's no guest operating
Operating
system.
system.
That is the main difference. Here there's a guest operating system. Now there's just follow.
This one has application software, the other one doesn't.
Exactly. This one is direct. Well, this one has obviously this is server software is the application software. This is software. It calls it.
This one has server software and application software.
Yeah. Okay. Not so important. That's not the main difference. The main difference is that's not the way I think of it. The main difference is that this container is sitting on a container manager on one. How many operating systems are here?
One.
And there's not how many different operating. How many total operating systems? One. How many total operating systems are here?
3, 4.
No.
Libraries
Ah.
are 86.
well, if you count these as 2, then 4, yeah. At least in my way, I would say there's 3. There's this one, and the hypervisor. Hypervisor is like a special purpose operating system. Like I said, in my opinion, this line should be removed. This whole box should be removed.
But the hypervisor might not be an operating system.
You're right. That's why they drew it this way, because the hypervisor could be designed to work. When there was a company called VMware, and when VMware first came out, they were working like this, but now they don't work like this. I mean, I'm talking even 10 years ago, they weren't working like this. Okay. In any case. Yeah, I'm actually probably the only teacher who teaches this stuff, except for Avi. Me and Avi are probably the only ones that actually worked with this stuff, so we'd actually know what we're talking about. Avi, some of the other teachers never actually work with this, but I remember when it was like that, and it's not like that. Anyway, the point is that here in the containers, there's one operating system. So how do we differentiate this server from that server? This is essentially a server. That's why it says server software. It is true that it is correct, because once we build the container, here, Shira, once we build the container, the server software is going to create for us a virtual server. We're getting a virtual server by this server software.
I guess what you're saying?
This server software really is correct, because that's what's giving us our virtual server, and that's what's giving us our server. But the virtual server here is in pure software. Whereas here, the virtual server is because we have a whole operating system set up. Here we plop down a whole installation of Windows over here and another installation of Windows over here on top of our hypervisor. Here we are using one installation of Windows, and we're in software separating out 2 virtual servers that feel and look like they're independent of each other. They can't affect one. If this guy crashes, he can't crash the whole computer. He can only crash the software. We've isolated him, but it's really on one operating system. That's the idea of containers, and that's what that woman in the lecture that I sent you, that I watched with you, shows you how to do. How to step by step isolate more and more the software from this software from that software, and this is very popular now. Dockers is an example of.
Wait, this is as opposed to the other one, right?
Yes, these are 2 different ways of creating virtual servers. Dockers is a popular way nowadays of doing containers. But I'm not going to talk about Dockers because
Wait, but what was it?
too much detail.
How did we differentiate between the different operating systems?
Oh, that was that lecture that you watched.
Mm.
How do we?
Oh, just by containers?
By creating a container in software. For example, what does it mean to separate? What does it mean to be separate? What does it mean to be separate is that, for example, if I can't take all the memory and you don't get any memory, right? Right? If one program, what does the operating system do? He manages memory. He says you get this and you get that.
Right.
But if
wouldn't separate mean like they just don't know about, like they?
no, separate means that I can't take. Separate means that I can't use up all the resources of the operating system to your detriment. And furthermore, if I crash, I won't cause you to crash. It could happen that on your computer, you're running some software and then it crashes and then you have to restart the computer.
Right.
So in this case, no matter what I do, if something crashes, I'll only have to restart a container.
Like if one of the programs freezes and doesn't work,
Then it's only in that container. It's contained. We've put it in a container. We've isolated. It should be called an isolation box. We've isolated it.
Isn't the container itself the operating system? Like it
No,
doesn't
it's a
exist
view.
before
It's a
there's
view.
container.
No, it's a view of the operating system.
But it's still separated before we even have containers. We just can't interact with them separately.
No. The container. First of all, you have to watch that lecture again.
I didn't understand a
Can
word.
you
You
send
didn't
it
say
on
the
the
word?
It was too confusing.
Can you send it on the group to rewatch?
Yeah, I can. Yeah, remind me. What she did there was she took a running operating system
Right.
and she said, okay, I want this program. I'm going to limit this program to only use a certain amount of CPU time.
Right.
Or CPU. I'm going to limit it to use only a certain amount of processes. You can't use more than this number of processes. I'm going to limit it in all this way. She's going to build a limitation on the software, and then she's going to create like in other words, she creates like a shell, like an environment in which to run software.
Right.
And in that shell, she puts all these limitations. So that when I do actually run something, it's subject to all those limitations that I built. So he's technically running as a system program on the operating system. The operating system sees it as a single program. But because of all those limitations, he can't crash the operating system. That's the idea.
But it's its own operating system or no?
It's not its own operating system. It is not its own operating system. That's why you only see the word OS once here. There's only one OS here. It's a containment field within an operating system. I wonder if I can give you
So
a
it's really more than one process that only affects itself.
It could be multiple processes.
No, I mean each container.
A container could be multiple processes.
A container
A
basically.
container
just whatever's
is a
happening inside
vessel.
of it is only
Container
within
is a
itself.
vessel in which I can put, is an isolation vessel in which I can put as many processes as I want to and create a server. That's why we have a server software. I can put all these processes to create a server on top of the operating system, but without being able to interact or interfere with other containers.
Okay, so it's basically like a safety mechanism.
Yes,
We do whatever we want inside of a container,
And-
it's not gonna affect anything else.
exactly. Yeah.
With the guest operating systems, that's still virtual servers? No, right?
Yes, this is virtual servers. This is implementing a virtual server as a virtual machine. This should be called, just to be parallel, it should be called implementing a virtual server through containers. That's what this should be called, instead of using containers. It should be called implementing virtual servers through containers.
It's just like a step above the thing you just saw.
It's a more modern version. It's a more contemporary version, but it's not better. It's actually, it's lightweight. It's a lightweight version of the other one. The other one, I need a lot more computing power because I need to be able to have a computer that can handle an operating system running on top of an operating system. See what I mean?
Right.
But here I can use a lighter software. I can use just one operating system because operating systems are very heavy. If I'm going to run two operating systems, everything I want to do is going to slow me down. So I need a very powerful, big computer. So here is a way of getting better results, better bitsuing, better efficiency, speed, and getting without having any problems of interactions, unwanted interactions. Okay, and I can have this as a dedicated server. As this could be a server for just producing the time of day, and this is a dedicated server just for doing the temperature of the day, of the time. And don't interact. Okay, Dockers is a way of doing that, is a kind of containers. Here's benefits of containers. You can look at that on your own. So we talked as software as a service, but there's also platform as a service and infrastructure as a service. That just means that I can hire from Amazon or AWS, I can hire from them a server. I can hire for them a server with a service installed on it, or with software installed on it. In other words, I could get from them just a straight empty computer, and then I put on what I want. That's the cheapest. Or I can get from them with the pre-installed stuff, like databases, etc. Or I can say, I want you to give me a server that tells me the temperature. You know what I mean? At any city in the world. I can ask for it as a service. And I'll obviously pay the most for for a software as a service. That'll be the most expensive.
Well, when we buy like a laptop, that's the software service.
No, that's nothing to do with what we're talking about. When you buy a laptop, this is buying a laptop. This is talking about paying monthly to Amazon for services.
Upgrading your Google Drive.
Yes, I can upgrade my Google Drive to be a server, and I can program it. I can actually put an operating system on it. My Google Drive will now be, right, Google Drive is a service. But it's empty. It's
When
just,
you upgrade it, you can then literally build
yes,
operating on it.
yes. But it wouldn't be called your Google Drive anymore, it'd be called a server. But essentially,
Regular, like you remember the regular upgrade,
the regular upgrade is just to give you more space.
Right.
But they could say, pay $90 a month and you'll get, in addition to what, you get a gigabyte of space and, what gigabytes, how much? 100 gigabytes of space and, a server too.
Well, that's like what.
And now you
AWS
can,
is.
what?
That's just
Yeah,
AWS.
that's AWS. That's what I'm talking. That's what we're talking about here. But my point is that when you buy from AWS, there's three things you can buy from them. You can buy an empty server. Essentially, you can do it like this: you can buy an empty server or an installed server with things already on it. Or you can have a third level where you don't even buy that; you buy a service. That would be like Google Drive. You could buy Google Drive from them. You could say, I want to buy. That would be software as a service. Google Drive is.
Like, I
That's
don't
what
want
you
to make my own cloud service that keeps my pictures and my documents, whatever, so I'll just take the one you have for me.
Exactly. Or I could just say, you know what, I forget this whole Google Drive, I'm gonna buy a server from you, and I'm gonna build my own way of storing pictures on it.
So essentially, just a server is just the physical space. Server, the platform as a server is.
Well, here we're using it as, we're calling it infrastructure, which is a good name. Infrastructure means hardware. But server infrastructure, server platform, and then server service and service. Service is what a server provides. But yeah, I mean, a server is just a computer. But we talked about it being a virtual computer. Here's cloud infrastructure, software services, and then software customers. In other words, the cloud can provide services like Google Drive, and here are all the customers using Google Drive. And Google Drive is sitting on the cloud. The advantages of software as a service is that I can see my monthly expenses. I have cash flow. I know what I'm spending and what I'm taking in, right? If I all of a sudden at the end of the year have to buy a whole lot of new servers, I didn't expect that. So here I have a cash flow. I know what money I'm spending out, what money I'm going in, and I can know if I'm profitable or not. Continuous deployment. I can rely on Microsoft or on Amazon to keep the server updated. Try before you buy it. I can get a month for free and see if I like it. The problems with it are regulations. There may be certain laws. If I want to have a pornography site, I may have difficulty in certain countries. But if I have it in my own country, then I can do whatever those rules of those countries are. But I may have regulation, bad example, but gambling. Maybe there's some countries that don't allow gambling in other countries.
Or like China with any social media, basically.
Yeah, China doesn't allow lots of social media things. So if I have it on a server that's in China, I may have a problem using it for a certain purpose, right? If Amazon puts their cloud in China, then all of a sudden they can't provide services that they used to. It would be illegal. Data security. It could be that a company, let's say a bank doesn't want, or the army doesn't want its data to be stored on Amazon, right? The army is going to have a problem with using Amazon because they don't want their data anywhere except in their own servers. Then we talked about tenants. What is here? We said this information leakage. Actually, this I'm going to stop reviewing here of this because the end of this slide section I have I uploaded 2 videos of that. That is on the thing.
Officially, class is over.
Class is over. All right. So we did a good chunk of review. We didn't review my slides, which is mostly about wait a second.
We have 6 of your slides.
Yeah, that's all.
But he said it's only 2 through 4, 2 through 5.
No, that was.
Can I ask a question? Can you hear me?